So, can you see the slides?
Yes.
Yes.
Okay. I will give a short overview about safety co-engineering and what are the main results from Arrowhead and Square. So, safety security co-engineering, as we understand it, is basically a combined approach to system engineering. It is clear not all activities can be done in parallel, but the goal is to have as many shared activities and exchange of information as possible in order to ensure that the system is built safely and secure. Motivated, I think, can skip this slide because most of us should know it. Security threats can influence safety, and security safety measures can influence each other. We have focused on two projects. One is Arrowhead. Arrowhead's goal was to combine multiple smart devices in local clouds, which should collaborate automatically and also interconnect these clouds. There were safety, security, real-time issues in few of these systems, and one main outcome of it was that for such connected systems, security issues from the cloud or from the backend can threaten the safety, and in the real-time or PLC side, some critical information can also be threatened. In Arrowhead, combined analysis for safety and security was developed because vulnerabilities or errors threaten in the end the same system properties: the safety of the system, operational parameters, or the confidentiality of data. Additionally, there was safety security measures developed, mainly a mediator, which is a secure and safe gateway for such a legacy system, enables the connectivity to some outside systems, and also protects the system against dangerous commands, which can threaten the safety or reliability. The second project is EMC Square. Main goal from EMC Square is embedded multi-core system for mixed criticality application in dynamic and changeable real-time environments. And for such systems, safety and also security is a major issue, because we are moving from a static, well-known, isolated system to open and changing system, where we are no longer sure what is exactly happening in advance. In EMC Square, the co-engineering was mainly based on the idea or the approach to combine processes, steps, activities from different standards. For example, one development was for the smart grid domain based on the generic safety standard, the IEC 61508, and a specific smart grid security standard. The approach was to look firstly at the safety or the failure rate of the hardware, then at the security and investigate the robustness of the system, and then estimate the safety integrity level of the combined hardware software system. So both in combination. In addition to smart grid domain, there were also approaches for the automotive domain, starting with looking at the automotive safety standard and the common criteria, which is a domain-independent security standard. Main focus was on the one side on the work products, so a comparison. Are there overlaps between work products? Can we extend some work products from safety or from security slightly in order to generate artifacts for both? and also on the required V&V activities. This comparison was mainly based on the strictness of the V&V activity. So when formal verification or model-based approaches were required in both levels for safety and for security, then the levels were considered similar or overlapping. And during the project, the first automotive cybersecurity standard was published, the SAE J Series 061, which is a much better fit for the ISO 26262 because it follows a relative similar process than safety, and it also considers three types of implementation or cooperation. So we can apply it as a standalone process, we can apply it coordinated with a safety process, or we can really apply it in combination, so conduct shared activities. So what is our understanding from this project, the goal of co-engineering? The idea is to have a basic lifecycle fits to the domain, which supports the engineering, and then add additional concerns via interaction or extension points. So look at the step and artifacts and work products required and see, okay, what needs to be extended or included in order to make this feasible for additional concerns. In EMC Square and Arrowhead, this was only done for safety and security and also only for the smart grid and automotive domain. But in our opinion, such an approach could be also very feasible to extend it to more concerns and more domains. So, any questions?
Yes, I have a question. What were the durations of these two projects? Are they finished?
Arrowhead is almost finished, so I think it's running a few months. EMT Square is still running a little bit longer, I think a little bit over the end of this year. April of next year, then it will be finished.
Okay, if we don't have any more questions, then we can move to the next speaker. So we have Gabriel. Okay.
Everything okay? We cannot hear anything.
Yes, we should have presentation from Gabriel and Morayo from CEA, but there may be a problem with setting up presentation mode on the web application. So we could, as Martin says, postpone the presentation. So we could move to the next one. Frédérique, ready?
Yes. Yes.
Okay.
So you give me the hand?
Yes, I will make you a presenter so we can start instead with you.
Okay. Okay. Do you see my screen?
Yes.
Yes, it works.
Okay, so I will speak about the MERRE project. So I will present the project and tell you about multi-concerns aspects that have been addressed in this project. I speak about the safety concept that we have expanded in this project from OPENCOSS point of view, and I will have a focus on our contribution because we were especially dedicated to some aspects that I am able to describe. I'm not able to describe the whole project. Okay. So MERGE is a project about multi-concern interactions, and it's now finished. It's just finished at the beginning of this year. And the purpose was to develop innovative concepts about safety and security concerns. So it was a little consortium with only French, Belgium, and Finnish partners, and we were able to work on many objectives, work on the safety and security aspects together, and how we can work on these concepts on an aligned model and adapt some tools to be able to handle both safety and security aspects, and propose how to test and validate these aspects thanks to new concepts and approaches too. So it's very similar to, I would say, EMC2 with a lot of common works, I would say. And we worked on 2 use cases from OPENCOSS point of view, but in the project we had 4 use cases. One from the communication domain from Thales, one from the industrial domain from Instance, one from automotive from Melexis, and one from aerospace with a space app assembly. And Allfortech was able to work on radio communication and aerospace use case, and I will speak a little bit more about the work we were able to do. The multi-concerns that were addressed in this project were about mainly 4 concerns, I would say. Performances aspects, and we didn't work on that, but Thales and Sense have tried to prove performances aspects in a model-based system engineering approach. And also the cost aspects were addressed by Thales and Melexis. The same idea is to have this global system engineering approach and to be able to evaluate when you are building an architecture, evaluate performances and costs together with the design of your architecture. And also to propose through patterns architectural solutions in order to better and quicker converge to the right architecture that is able to solve all the multi-concerns addressed in the model. And Thales has worked on that aspect. And also safety and security aspects engineered in the same modeling approach. So we have worked in the work package 4 that was dedicated to a state-of-the-art on multi-concern aspects, and I think that this work can be reused and merge work can be reused for our work package 4, and I hope that we can contribute with the merge works on that. And also we have worked on safety and security aspects, and we have proposed to continue this work in the context of AMASS project. So, Safety Architect, I already presented it, but just to remember, it's a tool that allows to import your MBSC model or to model your system and to perform safety analysis at a local point, and we are able to automatically generate the fault tree analysis and give all the reports useful for the safety cases. So we are using either a Papyrus or a Sirius modeler, and with our local analysis we are able to describe what are the impacts of the failure modes of the inputs on the failure modes of the outputs, and to define barriers. If the barriers are implemented in the architecture, it's just a way to explain that we have safety mechanisms, and if not, it's a way to express the safety requirements that we need to add in our architecture. And also there is an analysis of the impact of the failure of an elementary block on the architecture behavior. And after that, we are able to generate automatically trees with the propagation wave. That means that from the failure modes of the elementary elements of our model, we are able to see how they propagate through the model and how they reach a feared event. We are able to provide reports with mecha table or reports on critical paths, and reports on which kind of dysfunctional analysis we have made in order to produce the fault tree or the mecha tables. We also are able to export the fault trees in an open PSA format in order to be able to compute them with ordinary fault tree tools such as Fault Tree Plus or ArborAnalyst in France or any tool that is able to import open PSA format. So, what is the work we were able to perform in the MERGE project? We were able also to work theoretical aspects with analysis of standards such as the DO 326A and DO 356 that are more for avionics domain, and to examine what were their recommendations about safety and security co-engineering. And we also worked on deliverable in which state-of-the-art was done, and we tried to extend the model on failure modes, effect, and criticality analysis. It's very similar to what we have seen in the EMC2 project, I would say, and we have to work on the formalization in AMASS of a common approach. And we also have tried to propose a framework for a more formal security and safety assessment. And I will express that through the use case to make you understand the kind of work we have done. So the first use case we have done was with aerospace, and with them we were able to model an onboard control procedures engine. We were able to import this model into Safety Architect and to perform dysfunctional safety analysis and generate the fault trees and also the FMEA table. And we were obliged to adapt our tool in order to be able to be compliant with the aerospace standards that SAS and they was obliged to use. And we also were obliged to implement a plugin to be able to import their UML model, which was in the Magic Draw tool. So, for example, this is an example of the high-level model of the OBCP and the kind of FMECA report we were able to automatically generate from our safety analysis. I would say that in the context of MERGE, it was a little disappointed because SAS and they had no security problems, and it was a pure safety analysis, and it was not very much multi-concerned oriented. This was not the case with the radio communication use case, in which we were able to focus on the safety and security assurance. So the SDR system, which is a radio with a crypto aspect, because it's a radio for military exchanges, developed by Thales, and they used Capella as a modeling approach, and we were able to propose both safety and security analysis in order to generate both fault trees and attack trees. So the work we have done is to integrate the bridge allowing the import of the Capella models, and we have developed a new security view to perform the security analysis, and we also developed a safety and security common view to be able to see what are the impact of the safety and the security and vice versa. And also, we have worked on a more formal approach with ONERA, using the Alloy formal language in order to specify, to verify with the code tool. It's a formal verification of the safety and or security properties. So to summarize this work, we had the first model in Capella from the system, and in Safety Architect we are able to develop the security view in which we just express what is the effect of malicious input on the system outputs. The safety view is very similar to the Safety Architect approach. And then we are able to export these views into a code model using the Alloy language in order to formally find eventually counter examples that show that the feared events can be attained in this architecture. That's all.
Hello, this is Garasi from Technalia. Frédérique, I have a question regarding what you said before that. Hello, can you hear me?
Yes.
Sorry. Okay.
Please don't speak too quickly because sometimes it is cut. So please.
I will
slowly.
try to do it slowly. Okay. So I have a question regarding what you said, that we could use architectural patterns for task 4.1, or maybe I got it wrong, because this is not something that Work Package 3 should cover, or it's just to clarify it.
My idea is that we have in Work Package 4, we have to work on multi-concerns aspect. And I think that a lot of work has been done on this aspect in Merge. And for me, it's more Work Package 4 dedicated, but we can discuss that.
Okay. No, it was just regarding patterns, as I told you, like architectural patterns, safety mechanisms, or so on. That's why, But we can discuss.
Okay, I do agree. You're right. I think that we can also use merge results in Work Package 3. You are right. I do agree. In fact, I'm more concerned at the moment with Work Package 4, but it's my fault.
No, it's fine. Yeah. Just to clarify. Okay, fine. Thank you.
Thank you.
Okay, if we don't have any more questions, we can try again then with the previous presentation. But let's see. But we can't hear anyone from CEA. Unfortunately, they have problems with sound, with audio.
Hello, can you hear me? Can you hear me now?
Yes.
Very good.
Yes, so I can start.
Yeah, we can start, but unfortunately we cannot display the presentation using the application because we are not allowed to install this application.
Okay, then.
So probably the better.
I will start the presentation on my computer and share my screen so we can try to make it work like this.
It's okay.
Okay. Presentation starts.
Yeah, it's okay. So we can start now the presentation.
So we present the Sophia framework. We go to the Sophia global overview, and then we present the module we have for safety analysis, and Gabriel, we present the module we can provide in Sophia for security analysis.
Next slide, please.
So Sophia is built on, has an extension of Papyrus Modeler. It is provided has a set of UML profiles for different kind of safety and security analysis, and it is based on the system model we can build based on SysML and UML. We have different modules that target different domains like avionics, automotive, robotics, railway, and so on. And we have also modules for the requirement management and the system engineering in general with the architecture and so on. Next slide, please. So Sophia is built as a set of profiles. You have to design your model using UML, RobotML, or SysML within the Papyrus Modeler. And we can apply the profile to have different safety view or system or security view. So we have, it's not a co-engineering for now, we have a different view for each different kind of analysis. And the safety view is providing different kind of analysis for prevent the risk for accidents. And the security view, of course, is for limit the malicious risk. Next slide, please. So for the module for safety, we have 6 main modules. One for preliminary hazard analysis, one for the system hazard analysis. These 2 modules are still in development, but we have already some view we can present. We have then the failure mode and effect analysis module, the fault tree analysis module. One module is about the property verification to verify the safety properties and the reachability of some state. And then we have the requirement engineering module that deals with the safety related requirements and other requirements also. Next slide, please. So the module we propose are targeting the left side of, for safety, the left side of the V-cycle. So the hazard analysis part and the preliminary safety assessment part. Regarding the hazard analysis part, the module are developed in a way that we have specialization based on different standards. So, for example, we can provide the identification of hazard based on the ISO 26262 process as it is described in the standard, or on the avionics ones and the RobotML one. And for the preliminary safety assessment, so we propose the standard FMEA, FMECA, the FTA, and the module checking for the property verification. Next slide, please. So Sophia requirement is a global module, is not only dealing with the safety-related requirements, but other requirements, but we have support for the classification of requirements that are related to the safety elements. We can display the requirement on the models, and we can also have tables or requirement diagram, and we can also have automatic generation of the report for the requirements with the classification. So this requirement can be mapped to any element within the system. So the architecture, the safety analysis module, and the safety element, and so on. Next slide, please. For the preliminary hazard analysis, we try to identify and categorize the hazard and the potential consequence in a given operational context. So we have the situation analysis within the environment that we can identify the malfunction that can trigger any hazard in the system. We can then classify the hazard depending on what kind of standard we want to follow. For example, the ISO 26262, we provide the classification regarding the ASIL. We have the classification based on SEAL and DAL for the avionics ones. We can display the tables for the hazard classification and also the operational context within the environment, and provide automatic generation of reports with some the elements we want to provide, like for example a summary of what kind of hazard we have, the detail of the link with the different operational situation and so on. So is a set of different profiles to have different kind of classification. Either we choose to apply the profile within the Sophia PHR according to the ISO 26266, so then we follow the methodology based on this standard or based on the IRP, for example. And we have a different kind of report that can be generated for different kind of hazard analysis we want to perform. Next slide, please. So for the system hazard analysis, we try to analyze the functional cause within the system, given the accident scenario we identify during the preliminary hazard analysis. We propose a fault tree representation for this SHA, and we can add some barrier or safety measure, if you can call it like this, to prevent or correct some accidents. We also provide a generation of report for that, but this module was developed in the context of some specific projects, and we are still improving it to adapt it to any kind of PHA we can have, or different standards. Next slide, please. So the module about FMEA is a dedicated one to have an analysis on at the component level and check what can happen, like a failure in the system. So we have automatic safety annotation of the system model, and we can perform different kind of FMEA, qualitative one, just to show, for example, the criticality block within the system, and also some quantitative FMEA. We have automatic generation of the tables within the model. We have also the report that we can export in PDF or in Excel format. Next slide, please. Yes. So for FTA, we have also automatic safety annotation of the model. So we consider that each component can have a failure state. So in each element, we have the automatic safety annotation with this failure behavior of the system, and then we can have automatic generation of the fault tree like a diagram, or also with the OpenPSC format. We can provide qualitative FTA, so we are linking our tool with the FTA tools, but the link, the bridge between the tool is transparent for the user, and then we can have the minimal cut set analysis, the dysfunctional scenarios analysis, and so on, and also the quantitative FTA with different kind of report analysis that we can have, like the critical one, the diagnostic analysis, the sensitivity analysis, and so on. So we are using we are linking the Sophia module with the FTA and Altarica also to provide this analysis. Next slide, please. So for the model checking, we are linking the tool with NUSMV, and we first do the modeling of the failure behavior of the component within Sophia using a state machine, and then we have the requirements that are formalized using CTL in our view in the Sophia. Then we can make the transformation of our model into NUSMV language. And we can check if some states are reachable and so on, and the CTL specification. Also here, the link with NUSMV is transparent for the user. So that was for the module we have for safety, and then Gabriel will present the module we have for security.
Okay, so could you please move to the next slide? So, with respect to the module Sophia for security, well, this module is based upon a context that includes a target architecture, the security issues of the target architecture, and some solutions, countermeasures that we can propose to mitigate the security concerns. So this is the context in which the modules should be applied. And the Sophia for security approach consists of a risk analysis. Well, it's a risk assessment as it is defined in the international ISO standard 27005. And it's based upon a French method that is named EBIOS. And this method is intended to identify the security requirements a system should satisfy in order to accomplish its objectives. So basically, as a result of this analysis, we can identify the potential attacks, the associated risk, and the proposed countermeasures. So next slide, please. So here we have an example of a target architecture. It's an IoT, an Internet of Things. This is a multi-layer architecture. It's very complex. It's ubiquitous, accessible from multiple points. Components in this architecture usually interact with the physical objects, and that's particularly important because this is a kind of system in which safety and security are relevant, are important. So this is an example of the systems we can analyze with our module. Next slide, please. So the particular issues that we can identify in this architecture is that at field level, we have, for instance, local networks that are composed by meters, actuators, controllers, and the communication between these components is based upon protocols and channels that are not really protected or designed with security in mind. So there are several attackers that are interested in target this architecture. So the next slide shows how this slide shows a first view of the architecture we can design. So the architecture here shows a separation between the assets composing the architecture. We have defined some stereotypes to define what is known as supporting assets, primary assets, and network links. The primary assets are simply this kind of assets that have some value for the owners. This diagram is mostly based in BDD and IBD as they are defined by CSML 1.4. So on next slide, please. So once the diagram of the architecture has been accomplished, we can proceed to an analysis to identify the security, the threat scenarios that can target this architecture. We are able to specify, for instance, the sources of threats, to specify the scenario based upon the likelihood of this scenario to occur. We can, to initiate this analysis, we can identify the assets that are first impacted by the scenario, the abilities associated to these assets, and finally, the objective of this analysis is to identify the primary assets that are impacted by these threats. We have some stereotypes that are meant to specify the severity that the threats are imposing on those assets. And finally, the risk will be evaluated according to the severity of these properties that are violated. So next slide, please. So in this view, we can see how the threat scenario is used to evaluate the risk. So the evaluation of risk is based on what is known as a period event, as it is defined by the EBOS method and the international standard 27005. So it's basically a consequence of the intervention of these attackers. Here in this example, for instance, we have a modified consumption invoice, and there are several impacts that we can see here. For instance, we can damage the company trust in it. We can increase the operation cost of the company because it's necessary to correct this mistake, or even the loss of the client. So the evaluation of the risk is finally assessed in terms of the severity of the threat and the likelihood of the scenario. To track the management of the risk, there is the stereotype risk management, which helps, for instance, to follow the management of the risk when we add some countermeasures that are useful to cope with that risk. So the objective of this view, of this profile, is to facilitate, to provide some elements to the designer and to the user to visualize the progress and to help to assess the risk. So next slide, please. So finally, well, I have presented the approach, some views of these modules. So in this slide, we can list some of the most important features of the tool support. Basically, what we have here is that for security allows a smooth transition between between system diagrams, threat diagrams, and risk analysis diagrams. Because all these elements are reusable, we can simply drag and drop these elements and reuse in the different diagrams. There are some algorithms that are implemented behind in order to reduce the acquisition of user inputs. And the objective of those algorithms is precisely to reuse this information and whatever is possible. A part of a subset of this algorithm is deployed to traverse the diagram and facilitate the analysis of the architecture, the scenarios we are modeling, etc. And finally, what we have here is that this tool allows to generate reports in the form of tables. So basically, this is what I can say about Sophia for security. I don't know, there is another slide there. No, it's the last one, so if you have questions.
Hello, this is Wesker. Thank you very much for the presentation. Can you hear me?
Yeah. Yeah, I can hear.
I had a small question, and I understand that you are using UML diagrams behind these models, right? Or these are new diagrams you are customizing. What diagrams are you using for your security diagrams?
Yeah, exactly.
Are you using activity diagrams, something like that?
Yeah, this is, well, as you can see, there is a high-level analysis of the architecture, which is based on a black box approach. It means that each component is specified as a black box, and at this step, we have not seen any behavior. But indeed, we have the possibility to specify this kind of behavior based upon, for instance, state machine diagrams, sequence diagrams. I have not presented this part because it's a little bit short at this time. But yes, we have the capacity to specify the behavior of the components and to conduct this analysis as well. Yeah.
Okay, yeah, I understand, but my question was more technical. Then, because I'm thinking on how to use papyrus in the AMASS project. So, my question is, when you are creating new diagrams for security, threats, etc., are you using some existing UML diagram, or this is a new diagram you have created for security aspects? I understand that you are following the profile mechanism from UML, right? For your annotation, your customized graphical elements. My question is, what diagrams from are you customizing?
What diagrams are we customizing? Well, finally, what we are reusing. We have a variety of diagrams that we have already customized. So we are able to adapt to the needs of a client to provide the analysis the client needs. For instance, in the views I showed in this presentation, we have customized the block definition diagram, for instance. There is another view that I didn't show, that is the interaction block diagram, the internal block diagram. But the security analysis, for the security analysis you have seen in this presentation, we customized the class diagram mainly. And what else? Yeah, the class diagram.
So you are using these arrows, the association arrows, or the dependencies.
Yeah, exactly. And currently, what we are working at is at stereotyping these associations in order to specialize the analysis according to our needs. Yeah.
Sorry, just one small question from my side. I'm Stefano Puri from Intex. And regarding the profile, so are you using a brand new profile for safety and security, or are you reusing something from?
As I mentioned, as far as I know, as far as we know, we are really defining a profile that is based in this French method that is named EBIOS. EBIOS is a method that has been defined by an agency of the French government, so it's quite an official standard here in France. So for us, it's a good basis. And as far as I know, this is a new definition of this profile. Yeah.
Okay, thanks.
Do we have any additional questions? Otherwise, we can move on to the next presenter. Let's see. Okay, next we should have José Álvarez. Let's see.
Yeah, hello.
So, who will be presenting?
Me, José María Álvarez.
Okay, found it.
Yeah.
Okay. I hope you can install this small add-on for presentation from the web browser.
Okay. Let's see. Let me. Okay. Can you see the slides?
Yes.
Okay. So, and now, yeah. Okay. So I'm going to start. Hello, everybody. My name is José María. I'm visiting professor within the Carlos III University of Madrid. I have been working on different projects dealing with services, semantics, interoperability, cloud computing, and data-driven architectures. More specifically, the last years, I have been working on the European project Crystal, designing and implementing the OSLC services for the reuse company tools in the domain of requirements engineering. Today, I'm going to introduce you the main foundations of OSLC, covering the concepts of linked data and the main elements of an OSLC service layer.
Sorry, Jose, we just see the first slide here, so...
Okay. It was because I was full screen.
Okay.
Okay. So, afterwards, I will make an overview of the Crystal project to finally outline some potential interest for the AMASS project. So, as you may know, last years have seen the development of the semantic web. This is a term coined by Tim Berners-Lee in 2001 that looks for transforming the web of documents into a web of data. The semantic web, as a W3C initiative, is based on a common and shared data model, RDF, the Resource Description Framework, and RDF is based on a graph model that can be serialized in different syntaxes. On top of our RDF, it's possible to build domain knowledge, vocabularies, or ontologies based on different logic formalisms, supporting formal reasoning processes. So, the main building block of the semantic web is RDF. We can represent a graph just using a set of RDF triples, subject, object, and predicate. For instance, in this example, we can see that I am a resource which has a name, José, and I am a friend of other resource, Diego, that has also a name. These triples build an underlying graph that can be exploited in different manners and can represent different types of information. We can even build more complex graphs, including links between resources and literals. So, after some years of works and specifications and a lot of stuff on semantic web foundations, the linked data initiative emerged around 2008 to provide a practical view of the semantic web, in which the main idea was to represent data following the next principles. Everything has an URI. If you access a resource, you will get information. You can link together different resources, and you will access information via HTTP URIs. Furthermore, a model to evaluate how the information is published on the web was created just to establish a classification of the data sources. The objective was to create a real web of data under the Internet protocols. As an example, we have the linked Open Data Cloud that collects the main linked data initiatives in different domains, such as geography, documentation, government. The idea behind linked data is quite simple. Once you want to expose your data, you have to model what is going to be shared, and you should reuse vocabularies, concepts and properties, and other data sets as much as possible. For instance, in this example, we are exposing a resource, E1, and we are describing topics with or linking to external data sets. This new environment allows us to make a mapping between existing relational databases and linked data. So we have a data model, a graph, we have a formal semantics, depending on the RDF or OWL semantics, and a query language, Sparkle, that is quite similar to SQL. So this is just to give you a rapid overview of linked data. On the other hand, we have REST services that also appeared some years ago to easily manage resources on the web, migrating for an operational or functional set of services based on SWAP and WSDL to a set of resources that are managed under HTTP methods. So once we have introduced linked data and REST, let me introduce the problem of interoperability in the context of systems development. In this figure made by Mats Berglund from Ericsson, you can see that the development of complex systems implies the use of different tools for different purposes. Domain engineers are experts on using different tools, and most of times they need information that is generated in a previous stage. For instance, engineers creating models may need tooling requirements. Furthermore, engineers don't care about technical problems. They just want to use existing artifacts, data, and information. So finally, what we get is a tangled environment of tools and services that must collaborate together. So in order to address this challenging environment of tools and creating a kind of Internet of Tools, the OSLC initiative emerged to provide a service layer on top of existing tools, enabling data exchange through the application of the previous or the aforementioned linked data principles and REST services. So the main principles of OSLC are then those that can be derived from linked data and REST, such as the use of HTTP as communication protocol and RDF as a data model. Currently, we can find a good number of specifications in OSLC covering the main artifacts that are being generated during the development lifecycle, such as requirements, change, text, assets. These specifications have been led by main players in the industry, such as IBM. Yeah.
Could you please maximize your screen? We cannot read very well.
Okay.
If it is possible.
Is it better? Is it better?
Yeah. Yeah. It's not possible to change to the
because
yes.
If I use full screen, it just stops the presentation.
Okay.
Okay.
That's the problem. Let me see if.
Okay. It's okay. No problem.
That's okay. With a little bit of zoom, it's okay for us.
Okay, wait.
José, do you have two screens? Probably you are sharing the screen that you think that you are not sharing.
I'm sharing the PowerPoint. No?
Yeah, but I mean, normally PowerPoint opens PowerPoint application in one screen and the presentation itself when you press F5 in the other screen, if you have two.
No, I just have one.
Okay.
Oh. Okay. So let me continue. I was talking about the different OSLC specifications that are currently available as cycles. So they are covering the main artifacts that are being generated during the developmental life cycle. These specifications have been led by main players in the industry like IBM, Airbus, Siemens, or Accenture, and all of them are based on a set of core capabilities that are extended for each domain. So in OSLC, we have a tool that exposes a service catalog, domains that are implemented. A service provider is the implementation or the implementer of a domain. For instance, for requirements management, we have a tool like IBM Doors Next Generation and a domain, requirements management, that can offer an OSLC service interface to access resources, in this case requirements, that can be managed using the REST methods, get, put, post, and delete. And in OSLC, they also define specific capabilities for OSLC services like query capabilities, delegated user interfaces, and, well, yes, creation factories. So, a service provider offers resources. A resource is defined by a SAPE that contains a schema of what is being exchanged, actually, or mainly properties. For instance, in the case of a requirement, the text of the requirement, the author, other properties, for instance, who is validating the requirement, who is satisfying the requirement, all apart from, in general, what is being exchanged, apart of the content of the artifacts, are the metadata around the artifact. So the OSLC resource is perfectly defined and can be automatically processed by other parties that can take the SAPE, the schema of the artifact, and generate their own classes or objects to process those artifacts or resources in general. Here I have included some examples with IBM Doors Next Generation and just a simple client for Chrome. So we can invoke this instance of IBM Doors Next Generation and get the response, in that case, of the service catalog. Well, to be honest, this last week these URIs were working, but now I think that I don't have the proper credentials or something, and I cannot access the information. But well, the idea is that every resource that is exposed via OSLC has some URI, and the data that is being exchanged is RDF. So this approach to offer artifacts applying the linked data principles and REST methods has some advantages. Mainly, the standardized data exchange model based on linked data and RDF, and a standardized communication protocol and operations based on REST and HTTP. And when we apply OSLC to offer our data, we are going to actually reuse existing standards coming from the W3C mainly, or other standardization organization. However, we can also find some drawbacks. We have to pay some initial cost to deploy an OSLC layer on top of an existing tool. Resource shapes that defines which information is going to be exchanged are quite restricted, and sometimes they don't cover all the required information that must be exchanged. So this implies that every tool can make their own interpretation of the standard and create extension or extend properties that actually are going to break the standard. Sometimes there are no defined shapes for all types of artifacts. And finally, we can find also some potential issues regarding security and the query capabilities, since we are using a kind of restricted sparkle to access resources. Anyway, OSLC is a good approach to standardize communication between tools and between tools to exchange data. Regarding the support in the community, APIs, and so on, I think that these are the two main possibilities. The well-known SDK Eclipse Lio, and there is also another one for .NET. Nevertheless, this should be more updated or with more frequency, let's say. So, well, this is just an overview of OSLC link data, and just to conclude with this part, there are many OSLC connectors for different tools. No? This is something that we must to take into account. So the Crystal project. Once we have a general idea of which problem we are trying to solve, interoperability between tools, let me introduce the approach in the Crystal project. This is a large European project that finishes the next month here in Madrid. If you want to come, you will be more than welcome. There are around 68 partners. This is the budget. Large companies developing embedded systems, large tool providers, small companies also as the tool providers, and for industrial sectors, aerospace, automotive, rail, and healthcare. The motivation of the Crystal project is quite similar to the one I was previously commented in Ericsson. Different tools, different engineering methods, a need of data exchange, and a lack of a proper system to address all these needs. So, in the Crystal project, the approach is based on creating OSLC connectors on top of existing tools to support the different engineering methods. For instance, requirements engineering or simulation, to name a few, with the aim of enabling automatic data exchange between them and allow users to create more integrated and advanced engineering methods. Obviously, everything relies on providing a common interface to access and exchange data, what is called iOS, interoperability specification, and it's implemented mainly through OSLC services. In order to sort the type of domains that we can find in the Crystal project, specifications and services of the iOS layer were established according to the different types of domains and engineering methods. We have those that are part of the life cycle and those that are not. For each domain, it's necessary to study if there is already a specification and if such a specification covers all data exchange needs. In any case, the outcome will be the reuse and an implementation of some OSLC domain, or the extension of an existing domain, or the creation of a new one, reusing existing parts. So, in Crystal, we have been working on defining and implementing new domains that are documented in the next deliverable. In general, for instance, the university and the reuse company were working in knowledge management and KPIs management, but there are other departments working, for instance, in variability management and safety and risk management. They have defined shapes and services to share the information that is relevant for that domain. For instance, as an example, I am just presenting here some of the use cases or scenarios that we implemented with the reuse company. That is just to access the IBM DOS next generation via OSLC to gather the requirements and perform quality analysis of the requirements, generating the different metrics, no? That the tool, in that case the requirements quality analyzer, is able to provide to the engineer. We have also made a pilot to integrate such information within the IBM DOS next generation platform, creating a widget that, in that case, we sent the requirement to the requirements quality analyzer, and we present the metrics that are exposed, in that case, in the RQA tool. No? The metrics that are exposed via OSLC can be displayed, in that case, within the JAS platform. So these are just small or simple examples, and this is one of the complex or public showcase of the Crystal project. in which different engineering methods are applied to different or with different tools. For instance, I know that they use for requirements engineering IBM.NEXT, RQA. For simulation, they are using Modelica. For modeling, Ramses models, and everything is integrated in just one place. So here I just leave some references. And in the context, or one of the insights of the Crystal project that we have received from the reviewers in the European Union was about the sustainability of the iOS and all these domains that are now modeled as OSLC. So there is, I don't new, well, it's quite a new project, the CPCTs project, that is compiling all the OSLC specifications or domains or shapes, as you prefer, that are being generated in all Artemis projects and in general European projects. OSLC has also strong ties with existing W3C standards like the W3C Link Data Platform and W3C Data Shapes. OSLC has also some collaboration now with ProStep, that is an organization that is working in other ISO standards. And now the focus is on the application of this interoperability-based reuse for ALMs and PLMs. What else? Well, this is the approach in the CPCT's project, in which they gathered information from different projects and tools and connectors, not to have the whole picture of who is working on interoperability and which specifications can be extended or promote to a standard and whatever. So finally, I would like to situate the role of OSLC in the context of the AMASS project. Since we have several tools, engineering methods again, OSLC seems to be a good candidate to ease data and knowledge exchange, enabling tool interconnectivity. Let's say that we are aiming at a kind of interoperability-based reuse for assurance and certification purposes. Here we have to take into account that there are a lot of previous experiences, and we have to evaluate the use of OSLC as a key technology due to the foundations that are derived from linked data and REST services that are mainly standards for data exchange, covering data, the shapes, and the communication protocols. So I think that that's all. Thank you very much for your attention, and if you have any comment or question, I will be very willing to answer. Thank you very much.
Thank you, José. Just a question. I don't know if you will be able to respond now, but just to let you know, Jan from Capit company in AMASS uploaded the work package 6, I think, task 6.1, no, 5, sorry, 5 and 5.1, a summary of concerns regarding OSLC. Have you looked to?
Yeah, then they are very well addressed. I mean, they are completely true. There are some of the well-known drawbacks with OSLC. Yeah.
So, in the context of AMASS, from your experience, do you think what are the points do you think we need to take care to adopt?
Yeah. The point is that when you need to share data and information in general, one approach is to have some kind of centralized database. No? But to have this kind of centralized database, you need to share a common data model to model the, let's say, the instances or the objects that we are going to share, and you have to provide both, the data model to expose your resources and the communication protocol. This is mainly what OSLC provides us, a common data model with the option of modeling or extending existing artifacts, and on the other hand, the communication protocol, in that case, HTTP. And this is mainly to change from something like document-centric systems development to data-centric systems development. So, depending on the tools that are going to be used, and depending on the needs on communicating or exchanging data, I think that OSLC is a good candidate just to exchange, not to internally work on RTF, just for exchanging data. So I think, although maybe it's out of my knowledge, of my background, that we are going to have different shapes of information that can be shared using OSLC, and other tools should be able to easily read those pieces of information and process for different purposes. So this is the role of OSLC. But well, there are other possibilities. But in general, I think that is one of the unique options that combines both a standard for the data that is going to be exchanged and the protocol to access those pieces of data.
Okay. Thank you very much.
Okay, thanks.
Okay, if we don't have any more questions, then we can move to the next speaker, José Fuentes.
Yes.
You have the screen.
Okay. Let me share my screen and try to. Okay. Can you see my screen?
Yes.
Okay. Thank you, and good morning, everyone. My name is José Fuentes from the Reuse Company. We are a little bit behind schedule, so let me try to be concise on trying to show you the approach. My colleague José Álvarez, he introduced the Crystal project pretty well. So let me try to focus on one of the work packages in this Crystal project, the one for requirements-based engineering. So I will show you very briefly what were the main concepts behind this requirements-based engineering approach in the Crystal project, mainly based on what we call knowledge-centric approach for requirements management, and some other ideas coming from even projects such as the SafeCer project, such as the CCC approach for requirements quality analysis. And then I will introduce very briefly, because I believe that José Álvarez already did this introduction to interoperability approach in the Crystal project based on OSLC. So let me just start with very briefly with the partners that were involved in this work package 6.7. The Reuse Company on the one hand, University Carlos III, including José Álvarez as well, and also Office as the key developers in this work package, and Safran, Cassidian, and EADS, still with the old names before the rebranding, as use case providers. The main goals of this work package were to improve the quality of requirement specifications on the one hand. Of course, as I said, there was some previous work already done in the SafeCer project, so we tried to keep pushing some of these ideas coming from SafeCer, such as I said, the requirements quality analysis approach based on CCC. CCC stands for correctness, consistency, and completeness for requirements quality checking. The use of boilerplates and patterns to deal with the requirements quality as well, and to properly describe what should be the structure, the agreed structure for different types of requirements in the organization. To promote requirements quality in earlier stages of the life cycle, not only providing tools for quality checking, but also providing tools for the authors of the requirements, and to leverage all those topics by means of knowledge management techniques and semantic techniques. Finally, the last key goal and key point in this work package was to deal with interoperability issues for requirements. That's specific to requirements, and as you know, it was based on an OSLC approach. These are the main tasks for this work package, and here you can also see what were the use cases interested in each of those tasks and tools and bricks. So let me just introduce this knowledge-centric systems engineering approach, including the 4 elements that you can see here in the screen, starting with the system knowledge repository. So our approach was to develop this system knowledge repository, including mainly system knowledge base, as you will see in a minute, just describing what is all the knowledge for a specific business that could improve the way of checking the quality of our requirements. So this system knowledge base in this for this approach was mainly based on the definition of kind of ontologies. Probably it is not a fully formal ontology, but in this approach, our ontologies were made up of 5 different layers. We're starting with the inner layer, which is the terminology layer, where all the agreed concepts were defined in a sort of dictionaries, together with some other different types of keywords or terms for your domain, including also not only the business-oriented terms and concepts, but also some other forbidden terms or keywords. Remember that one of the key points here was to deal with requirements quality checking, and in terms of quality checking for requirements, normally companies are dealing with lists of forbidden terms. So all these terms were served in this and agreed in this terminology layer in the system knowledge base. Second layer was dealing with linking together all these terms. So in form of thesaurus or knowledge maps, the intention was to provide extra semantics to these concepts by classifying or clustering together concepts with a similar role in our project. So, for instance, all the stakeholder names together, or the names of all my components or parts or whatever, all together in the same semantic cluster, and so on, and to link also these concepts by means of different types of relationships. The third layer was dealing with patterns. In this approach, in the approach of this work package, we describe the concept of boilerplate and pattern that you will see in a minute, just to describe what is the proper structure and the agreed structures for the requirements in an organization. This pattern layer is coming very close together with the formalization layer, which is the way by means of fitting or matching one specific boilerplate, a requirement could be formalized, transforming a textual requirement into a kind of semantic graph. And then finally, we have our inference layer. that in our approach, this inference layer was dealing with the consistency and completeness checking based on different rules, as you will see in a minute. So in terms of the third main block, which is, as I said, the patterns, this is just to describe, on the one hand, what should be the boilerplate or pattern to describe different types of requirements in our organization. So the first task for this approach, for this boilerplate approach, is to describe what are the different types of requirements to follow. And the second and main is to describe what should be the greatest structure for these types, for each of these types of requirements. So if you manage all your organization to follow this set of agreed upon patterns and boilerplates, then you will get a consistent way of writing requirements in your company. And also, if you deal with the agreed dictionaries and lists of agreed terms, you will have also consistent vocabulary across your different requirements and documents. So you are now leveraging the quality of the requirements by having all these consistent requirements definition. And of course, in order to deal with this approach, the starting point is textual requirements. So we have to deal with the proper indexing, parsing and indexing of the requirements. So this semantic indexing approach is made up of the classical steps in linguistic tools, starting with the tokenization, normalization, disambiguation, pattern matching, and the final step of formalization. Of course, we don't have time to explain all these different steps in the indexing process. But this indexing process, as I said, allows us to start with the textual requirements, such as the one you have now on the screen. First, identify whether any of the agreed patterns that we may have in our system knowledge base is matching with the textual requirements. In this case, this example is matching with this pattern. Following step is to provide the proper semantic graph describing the contents included in the requirements. And then after this formalization, of course, this formalization allows us to proceed with the quality analysis of our requirements based on these three dimensions: correctness for individual requirements, and consistency and completeness for sets of requirements. And also, this formalization also allows us to provide a semantic search engine in order to look for similar requirements, on the one hand, to avoid duplicated requirements in your projects or in your documents, and on the other hand, to promote requirement reuse based on fine-grained search engine for requirements. So, all this system knowledge base approach and the definition of the knowledge behind a specific business domain allows us to provide, as I said, requirements quality checking. So one of the first questions that came up during the project was what are the requirements quality attributes that we should be focused on. So you can check different standards in the market, IEEE 830 or ISO 29148 and some others. All these standards are aiming to describe a number of quality characteristics. So all these quality characteristics are very nice to have, of course, but to some extent, what we saw is that indeed they are not smart enough as to be implemented in a tool. I mean, all these quality characteristics are nice to have, as I said, but they are probably not specific enough as to be implemented in a tool, or they are not measurable. So the idea was to transform all these quality characteristics in something more tangible and more easy to implement. And we found, of course, some help in other very nice document, which is the OPENCOSS guide for writing requirements. This guide is describing a number of very high-level quality characteristics. But the key difference with regards to the other standards is that this guide also includes an additional section describing a large number of different rules, provided that these rules are now easy to implement, easy to measure, are very specific, and are, of course, aligned with one of the high-level quality characteristics. Okay, so having this as a starting point, we described, and of course, having all the previous work already done in the SafeCer project, we describe a number of different metrics across all these three dimensions: correctness, consistency, and completeness. So just to provide some few examples for correctness, meaning how to analyze the quality for individual requirement, we already implemented some rules based on attributes, links, versions, and so on. All the rules based on compliance with different patterns and boilerplates. All the rules to check the conformance between requirements and information that may come from different models, SysML models or other models that could be represented in our system knowledge repository. Then the fourth type of correctness metrics are based on some sort of linguistic algorithms, including the detection of passive voice, imperative tense, and so on. Some other more easy to address, such as text length, misspelling. And then finally, the last block of correctness metrics are those based on lists of forbidden terms, such as or constrained terms, such as the use of ambiguous terms, or the restricted way of negations or pronouns, or mandatory use of shall and other similar keywords in your requirements. So we ended up in the project with over 70 different metrics for correctness, and the possibility to describe a set of parameterized metrics, and even custom code metric, allowing every user of these tools to even provide source code for additional metrics linked to the tool. Then for completeness, I may say that in terms of requirements quality analysis, completeness is one of the most challenging topics. It is very difficult, or let's say it is almost impossible to say, okay, this is complete. So what we do is we don't attempt, we don't try, we don't dare to say, okay, this is complete. What we do is we say, okay, we found a source of incompleteness. We will never say, or the intention of this work package was not to say, okay, this document is fully complete. So the idea is to be capable of comparing the information that is gathered from the requirements based on the previous indexing process that I described before, with information that we may have on models. So, for instance, if we compare information in a product breakdown structure, in a block diagram described in SysML, we can check whether we have the proper information also in our requirements, or if we are missing something. Another example could be, for instance, the definition of interface dependencies in your models that could be checked accordingly in your requirements to look for completeness, or to look for gaps in the definition of the requirements. And the third dimension in terms of requirements quality checking was consistency, where we can provide different dimensions for consistency as well. One is to try to detect lack of consistency between the requirements within your specifications on the one hand, while on the other hand we also try to look for lack of consistency between your requirements, textual requirements specifications, and the information you already provided in your models as well. So very quickly, this is similar to what my colleague José Álvarez already presented. We implemented some sort of consumers and providers, OSLC consumers and providers, mainly for requirements management OSLC domain, but also, as José said before, also for different, some other different domains, such as knowledge management domains, where which allows us to share knowledge information coming from the system knowledge repository to the tools that we implemented for requirements quality check. Okay, so I don't want to keep speaking about this topic because José did it pretty well before. In terms of dissemination, we have presented this tool in different international congresses and days and everything, starting with INCUSE or CSDM, Nordic European Systems Engineering Days, South European Systems Engineering Days, and some others. Right? In terms of exploitation, we ended up with three main tools: Requirements Quality Analyzer, Requirements Authoring Tool, and Knowledge Manager. Very briefly, Requirements Quality Analyzer allows you two different tasks. On the one hand, Requirements Quality Analyzer allows you to customize the way you want to check or to analyze the quality of the requirements. Of course, even if there are pretty good standards or guides in the market on how to write requirements, every different company is different, of course. In terms of maturity, in terms of the business, and many other dimensions. So even if Requirements Quality Analyzer allows you a set of out-of-the-box number of rules, the idea is that you can tailor or customize these rules according to your specific needs. And we use this RQA to do so. Once all your quality rules are described in Requirements Quality Analyzer, it comes to Requirements Authoring Tool to allow requirements authors to write requirements by having all this quality check on the fly. So all these two tools are not requirements quality management tools. These are, let's say, plugins on top of most typical requirements management tools, such as IBM DOS or DOS NG or PTC Integrity or some others, allowing you to check the quality of all the requirements that you manage in these other requirements management tools. So RAT, which is in fact a plugin on top of some of these tools that I mentioned, allows you to have all this quality check on the fly based on the rules that you already described in the Requirements Quality Analyzer, and on the other hand, based on the dictionaries and patterns that you can describe in the knowledge base by using the third of these tools, which is Knowledge Manager. So that means that in Knowledge Manager, you can deal with the definition of these glossaries, dictionaries, taxonomies, ontologies, and patterns. And all this information is further used in the authoring tool to write requirements with the help of all this information. And finally, coming back to RQA, RQA allows quality control teams to check whether the rules that they already described with this tool, with RQA, are followed by all the requirements that you may be writing, either with the requirements authoring tool or directly in your requirements management tool. So these are just some screenshots on this one is for RQA and the way it connects to different requirements management tools to gather all the requirements in these tools and to provide some reporting and charts on the level of quality for these requirements. This is one advanced view of the authoring tool with a blank text box to write your requirement on the left-hand side, with the quality recommendation and the rules that you broke in the right-hand side, and with the help of buttons here in the top, you select the type of requirement you want to write, the specific pattern that you want to follow, and here you have the help of the tool providing some terms and elements from the dictionaries directly to you, the author, to provide a consistent way of writing in terms of consistent structures based on the patterns and consistent vocabulary based on the terms and vocabulary coming from the knowledge base, right? And finally, this is the Knowledge Manager, which is the tool we used to describe dictionaries, such as you can see here in this screen, or link concepts together, or classify concepts, as you can see here in this product breakdown structure here in the tool, or the definition of patterns and grammars for your requirements, right? And that's all from my side. I don't know if you have any question.
I have a question. If we suppose that we have two subsystems which are composed in a bigger system, and both or all of these subsystems have their own ontology. Is it possible to somehow merge? Is it supported by your tools, the merger of those sub-ontologies into a bigger one?
Mm-hmm. Yeah, this is a very good question. This is something that was intended to be one goal to be addressed during the Crystal project, but in the end we didn't manage to address properly this topic. So, as you said very well, in our intention is to address this topic during the AMASS project. We believe that it is fully necessary to deal with this collaborative way of building ontologies, let's say, and to share the building of this ontology with different levels, including subsystems and so on. So this is one topic to be addressed during AMASS, definitely.
Thank you.
Okay.
I have another question.
Yeah.
I was just wondering if there is some kind of help for the user to choose what are in the case of a conflict between requirements, to decide which is the one that is the correct and which is the incorrect. Yeah.
Yeah. Normally, the tool will just detect the conflict. So, for instance, a very easy to understand conflict is when you write a duplicated requirement. So, for us, duplicated requirement, overlap requirement, is not just to be literally the same requirement written exactly in the same way. What we do is we transform, as I intended to represent here. We manage by means of your patterns. We manage to transform this input, this textual input, into a semantic graph. And what we do to deal with this detecting overlap or duplicated requirements, what we do is we try and compare information in the semantic graphs and not information in the textual source. So once we detect two requirements that are overlapped, what we say is, okay, there is a conflict between this and this other requirement, but the tool is not, we cannot say which ones should remain and which ones you should remove. And it is similar to the rest of consistency rules. We identify the conflict, but the tool cannot say, okay, this is the good one and this is what we have to change or remove on the other side. This could be a nice topic, but not addressed yet.
Yeah. Okay, another question is that in your slide, the syntax of for specifying the requirement seems to be very related to a functional security requirement or a safety requirement, and I was wondering whether this kind of syntax can or has been applied for the specification of security requirements.
Of course, this is just the example you have in the screen is just that, an example. The idea is that by means of the third of the tools that I described in my almost my last part, in the last part of the presentation, using Knowledge Manager, you can describe your own patterns. And you can describe the semantics that you want to use in your patterns. So, for instance, in this pattern, you can see that there are some elements enclosed between angle brackets. That means that for this, in angle brackets, we are using some sort of semantics. So, in many cases, security, safety, and many others, you have to deal with different, with new semantics to be involved in your patterns. So by using Knowledge Manager, you can describe your new semantics and you can describe your new patterns based on these semantics. So this is fully...
Thank you.
Thank you. Any other question?
Okay, if we don't have any other questions.
Thank you.
Then this concludes the session. I will make the recording available on the SVN in the folder for this particular session. Okay, thank you all, and bye.
Thank you. Goodbye.
Goodbye.
Bye.
Bye. Bye.